Hey everyone, thanks for that warm introduction and thanks for this conference. I'm trailing off a very awesome company here. I will try to do my justice on where we are at. So we're STRATIFYD, a B2B visual analytic platform for enterprise. And today my talk is going to be in pursuit of augmented intelligence. I'm more like a live one, so I'm going to walk around the whole stadium for this demonstration. So at the beginning of this, when we started all this conversation of journey of in pursuit of augmented intelligence, really I need to bring out the background, where we come from, right? So I was at the UNC Charlotte, I was of their research professors way back in 2012. And a lot of my project was doing with Homeland Security, DoD, DARPA, and Defense Production Strat Agency. That one thing that triggers the whole idea of thinking about augmented intelligence. And by the way, I'm not here to introduce our products. I'm not here to brag about our awesome company. I'm here really to show a new idea or metaphor how data scientists need to be involved, because I have deeply involved in establishing data scientists and business analytic program in the UNC system. Now, where it starts is when we're having this project, when all this Internet of Things, social media, internal customer feedbacks begin, people trying to understand, is there any way that without training or without educating everybody in our organization how to write Python codes, how to do R analysis, or for them to better understand insights coming out of any data source? One practical scenario was this epidemic prediction, right? We were working with Defense Threat Reduction Agency, really trying to see if I give you 10 million social media data, just by random, coming from either the Chinese social media or the US social media, it doesn't matter, right? Can we really understand a college graduate student from the CDC to help them to see if there's any pattern that could lead into any epidemic threat that they should pay attention to? Now, what we have back in the research when we're doing this is really we spend a lot of effort trying to find in a way that if there's any unsupervised fashion that can really read through all those tweets, all those microblogs, and getting a summation of what people have talked about. So let's see, on day one for this 10 million microblogs information that around this, by the way, this is an imaginary city where we're doing our exercises at, you start seeing people reporting, I have a terrible feeling, I have my headache going on, hey, this pain sucks. All those information being automatically summarized into different topics, into different groups. But more importantly, alongside with those topic summarization, all that, is where you start seeing a geo hotspot or all those millions of documents. So right away, people look at this and say, oh, there's something going down in the center of the city. There's a big bubble of people complaining about their house. However, at this stage, nobody really knows what's going on, what's actually happening, but closely using time series analysis, all those relevant information to monitor the development of the situation. Now, on day two, as you can see, with the same automatically unsupervised learning method, you start seeing developing more flu-ish symptoms, like coughing, like I'm feeling cold, but one of the things that they keep reporting is, yeah, this pain really sucks, right? So the situation, their thing didn't change. However, it becomes interesting in the geographical pattern is overnight that people who were reporting all those symptoms migrated to the west side of the city, which if you can look at the map itself, it's more of their residential. So it makes sense. People get out of work and they go home and they still feel sick. So that thing continues. Now, since it's become extremely interesting on day three, if you keep monitoring this event happening, you start seeing right away the geo patterns start changing, right? It becomes a breakdown into smaller clusters that done by our automatic algorithm. And as you can, if you close look at this, I think everybody would already guess, all these are urgent care centers, all these are hospitals, suggesting people actually went to those emergency areas for treatments or seeking for beds. But then, since it's become even more interesting is if you start looking at the terms, the way people describe themselves, this thing is killing me, right? They have more pneumonia, like symptoms like shortness of breath. I think this is flu, and my health is really declining. Now, this is a censored version of what people actually say. right? If you want to look at the uncensored version, you can look at the actual data, but people are really in pain. Now, at this point, 3 days in this event, you don't need to be a well-trained PhD in this area to know there's something going down in this area. So right away, when people start seeing this, they start coordinating with our CDC friend, our emergency responder friends, to say, hey guys, I really think based on what this machine is suggesting, and my prior experience, like just common human knowledge, I think there's something going down on them. So this project became a starting point of why we founded STRATIFYD, right? Right after doing that post-mortem analysis of all this event going on, what really triggers me is we always talk about human intelligence, which is always from us. As a human being, we learn knowledge, we accumulate all this. And on the other hand, people are always pushing for this artificial intelligence that really trying to just dominate all these analytics by themselves. Where's the balance? Now, to talk about the balance, we need to look back into history. Human versus artificial intelligence is not a nuance. It's not a new term that people are doing. Back in '97, the first Deep Blue that was built by IBM, which is a chess-playing computer, was hosted a program with Garry Kasparov, grandmaster in chess, right? So Kasparov lost, unfortunately, to the computer. And let's not forget this pretty sad phase, but the problem behind that is Kasparov said, as a grandmaster, I only see one play for my next one. I just want to see that one very well-defined chess play. But for computers, you can have thousands of plays simultaneously and pick the ones that has the least resistance. Now, that's not the end of it. Things just become very interesting after that game is Kasparov and their friends actually started a tournament called Men vs. Machine Championship, which is really trying to find out, are us humans really getting beat by computer for all this time being? Is there any chance we're going to win over artificial intelligence? So the concept of augmented intelligence actually started bubbling up or contributed by those folks, where they start doing things very interesting, like pairing grandmasters with one chess program, where actually the human won over the Hydra, which is an advanced version of Deep Blue that also built by IBM back in 2005. So that observation or that experiment says, if I'm a grandmaster and I have some computational model that help me to get a broader view of what I should do next, there's a chance that I can build pure artificial intelligence or pure chess-playing games. But this becomes more interesting, and this is actually one of the fundamental things that we realize why there's a new paradigm for data scientists, is they also started amateurs with 3 chess-playing programs. Like amateur like me, chess game, they give me 3 different programs that give me more information that come out of the 3, and I, based on my knowledge, going to pick which play I'm going to do for next. It actually beat Grandmaster with one simple chess program. This is some scary facts, right? The scary fact is, people like me holding a PhD, spending 4 or 5 years in doing research, will be obsolete. Because a lot of the knowledge is going to be offshadowed by computing. And if people that has their own knowledge going here, that they can borrow the computing information and then actually learn this thing faster or solving the problem faster, then that doesn't require you to go through a very long, extraneous training. Now, is that true? How can we accomplish this process? That goes to the question that we deep down looking at the recent development of the computing industry research area. What we come up with is to say the how is actually not just giving you the data. Because a lot of people are saying, hey, we have a lot of data that's stored. One of our clients has 40 terabytes data. They just bought EMC system running it. But if you look at all this data set, especially in this world of a massive amount of different data, 10% of those data are structured. Structured meaning those you have in your organization stored in the Excel, stored into any type of format that you already know what is structured on it. About 10% are unstructured. And when I say unstructured, this is purely unorganized, maybe just machine-to-machine logs, those are the things that are not predefined at all. But most of the body of your data are semi-structured. About 80% of this are semi-structured, which means that you will have a lot of defining characters. For example, you have different demographics information associated with free-form textual feedback that come against one of your products or the ones that you want to sell to an architect. So that's a lot of complex data format for organization, for even people to consume all those data. But without any method, it's not going to tell you what are the insights, how you're going to use it, right? At the end of the day, when we have this data, when we have all this, we're trying to solve a problem. But also, the reason why it's not in the raw data is that you can't really always trust in the data itself. So I call this data, right? So data can be incomplete. Everybody probably in your daily work already experienced this. There's nobody who's going to complain, hey, state that I have a complete data set for in any regard, because data can evolve. We're accumulating more data, and there's more information alongside with the data coming in. And also, data themselves or data itself will have conflict, right? If people remember when back in the 1990, 2000 year round, everybody is trying to map out the ontology, which is the entity of the whole world, that really to say, let's do a top-down approach. Let's really use our human knowledge to say, hey, here is the animal kingdom, and this is how things will lay out. But that didn't work, because in a working environment, in an actual world solving problem, people's perception of the world, which translate into ontology, are different. You can't have one and done ontology or a one and done kind of data structure that can you imagine that would solve all the problem. So all that lead to the most dangerous things in the data that we're looking at right now are the uncertainties, right? If you don't know what's in the data, how confident will you be in the insights that are extracted by any algorithms out there? Exacerbating this issue is that with the development of all this data coming all over us, IoT, social media, corporate data, inside and out, you got data become having physicalities, right? Data have locations, data has time that bind into it. Data also have sociality, which you have social connectivity, human to human, human to machine, machine to machine connectivity. Everything become very complex. So to solve the problem, then people were saying, hey, let's just apply analytics. Let's find people that really wrangling the data, getting all this done, and then telling a good story out of it. But do you know that in any organization that doing analytics, on average, there's more than 80% of the time, of analyst time, actually spent on not really understand what the insights of the data is, but rather wrangling your data, meaning cleaning it, finding data sources, needling thread all different data, and trying to get answers. And only that 10-20% are used at the analytic phase. So that's requiring a lot of hand integration with the current infrastructure and current platform that people have been giving out and filling out, right? Now also, the analytics itself is lack of human intelligence. A lot of the way that people are teaching the algorithms right now, me myself included, back then, was we're just talking about the algorithms. We're just talking about how this mathematically would apply, but really taking things out of context, what problem you are solving. But then without placing things back into the context, you're just learning again a methodology that may or may not work, or may or may not be accurate just in a programming language like that. So that leads to when we work with a lot of business organizations, Fortune 500 enterprises, is that people are analyzing data with their gut feeling. They're saying, hey, I see this, I will just go down the path and then spend weeks, months, really chasing down until they hit the wall and say, oh, no, actually this is wrong. Let me turn around and go back and do another route. So that agile analytics, that flexibility is really not being reflected, which is much needed in organization, but it's not reflected in nowadays approach. So that's why we went down the path of trying to think about augmented intelligence. So what is augmented intelligence? It's simple, right? That's what we're saying. Can we actually find a balance between the art, which is the human analytics, which is our normal knowledge, we're in the business area, how we're addressing the problem, with computational models that actually provides results or insights or leads or guidance about how people should solve that problem. So, give you a great example, right? Robert Downey Jr. I know this is Hollywood, so everybody knows who he is, right? This image itself illustrated perfectly. That's the human. All these cars and everything, that's the computation, right? And then the iris of our RDJ himself is the interface, is the bridge between all that. But by the way, I love the movie, I love him, I love Iron Man. This is the worst UI I've ever seen. I have no way to understand what's showing up there. He did a fantastic job, didn't he? But I would get lost so much by looking at this. But that illustrates a very well confined idea that we build our system, we build our company based on, is to find a balanced interface between offline data analysis with online interactive visual system, right? So what we're looking at here is a new paradigm, is the business intelligence plus artificial intelligence equals to analytic reasoning facilitated by visual interface that will later on be consumed by us human, by us analysts, by us business person. How are we doing that, right? You were talking about a lot of the unstructured side or semi-structured data. How are you attacking this issue? So our fundamental belief is all this is basically meaning we are hiring thousands or tens of thousands computational robotic minions. Now we'll run around, read all those unstructured data, read all those structured data for you, and then in the core engine of what we build, doing all those deep learning, neural network, and all those modelings by itself, and then using the visualization at the end of the day to bridge all those information back to us human. Like everybody's saying in 5,000 years, a picture worth 1,000 words, right? So at the end of the day, human consuming data using visualization, using visual guidance is very effective, but a lot of the heavy lifting should be done by the computation itself. So this will lead you to your widget analytics, right? Widget analytics is to help you to start something that is very focused in certain contextual environment where you can start pivoting not both the physicality as well as the social aspects of your data, making your analytics more nimble and agile so that you don't need to gut fit in one way and then need to come back later on, that just realizing waste of months to do this. But in addition, is that really to give you, in the system itself, data on demand. So we have over 50, 60 different data connectors that if you are saying, hey, I'm a market analyst, I want to see how my product actually being perceived on Amazon, or how my competitors' product being perceived on Amazon to do a competitive analysis, one button in the system. You can bring all those information in your analytic dashboards without you needing to scraping the website or you needing to do anything. And then fusing all different data together within the dashboard, within the work environment, in the system that will truly help you to bridge the gap in between different data sources, both inside and outside your organization. Now, all this comes down to user-centric analytics, right? All the dashboarding, all the visual representation is powered by computational results. So nothing you see here is not pre-computed based on different models, based on different domain experiences that are being built in to the STRATIFYD core engine itself by our data scientists or by our engineering efforts. All this will latch on, like I said, the new paradigm is invisible computing, right? For our survey of the business analysts, they don't care if this is runs on AWS. They don't care if this runs Spark. They just want to do their job, analyzing the data, tell their bosses what the findings they have, help their directors to understand what next direction to go into, and make their business better. So all this, what we're doing is invisible computing. We're not going to say, hey, we're using Hadoop or using all that. That's not it, because the end user we're looking at are data scientists like you guys or business analysts like you guys to empower you with the platform itself. So, as I said, we've been utilized by many of the Fortune 500 companies. One of the companies, they actually Just say, hey, let's do some fun problem. Let's find people that do an A/B testing between our existing practice versus what Stratify is offering here, right? So they were trying to analyze in a simple 37,000 feedback from their support system, right? On one side, they use menu, they put up data analysts on it, trying to find out what are the key reasons that people are complaining about the product or what they can improve on the product. So it took all those analysts, they can only analyze 10% of the data in 12 hours, spread it out over 3 days. Believe it or not, us humans will get tired by reading textual data or by looking at the semi-structured data itself. So that's as fast as those folks can accomplish in 12 hours in 3 days. And then they made a lot of judgment calls. This is the key here. That's a lot of gut feeling, as I said. But they can actually find out the key top findings, A, B, and C from that data set. In comparison, when people using our system with 1 hour training, they spend nearly 35 minutes to look at the whole 38,000 document or feedback that they're getting. And then not only can they find the ABC, but they're rather very confident of those processes. There's no gut feeling or there's no very biased decision being made because all those representations and information are presented to the end user. Now all this leads to another use case where we sell to a different Fortune 500 company. And I'm not supposed to put that name on there, but they actually gave more than 10 different data sources that connected into our system, and then the system can help them to look across all those different data sources and then help them improve their analytics, improve their data-driven process by tenfold. So the result in here, what we're building within this augmented intelligence platform is truly to, number one, bring analysts, any analyst, to become a computational powered data scientists or data analytics people that banking on data analytic methodologies, and then really helping people to, in real time, at a scalable level, to understand those data, those information that may be impacting their business. And then we are also, one of the things internally we call this, we're making data analytics sexy again, is that we're embarking all this new advanced technologies like AR, like virtual 3D interactions that we're pioneering in those segments to let the people are better being augmented by the computational power and better extracting insights coming out of their data set. So the key takeaway here, as I think I'm drawing close to my speech right here, is that all this data analytics is one key thing to remember is context, context, and context. Any data analyst and from any organization need to be focusing on what the problem they're solving, but also utilizing both your human knowledge as well as the computational results in the right way that you can easily digest and move forward with those integration. And one of the things that we have always looked at and doing as in STRATIFYD is to industrialize big data analytics, because as you can see, our product is a general cross-platform solution that actually could be utilized in different industries as well as different data sets. So yeah, thank you. That concludes my talk today. And if you guys are interested, here are my contact information. Appreciate it.